Welcome to Capgemini BICG University vLearning Course 701 for Oracle Endeca Information Discovery 2.30. This is Day 1 and the Overview section. I'm your virtual instructor, Thomas Dodds. Pools Custom Pools has grown quickly into a national chain of pool sales and installation dealerships. While they enjoy the growth, they're concerned that they continue to offer high-quality products and can exceed customer satisfaction through the proper channels within the dealerships. They have structured sales data from their data warehouse and have recently acquired feeds of data from the Twitter sphere and are looking to see what dealerships are performing well versus those who are not. The data that we'll use for today's instruction is a very simple star schema. Our sales facts are comprised of units and dollars. Dimensionally, our customer scores will have a score, a rating, and some comments. Our dealers will contain regions, district, and dealer information, including latitude and longitude coordinates for spatial analysis once we get to Studio. Periods of time would include week, month, and year. And our pools include the brand, the color, and shape, and a combination of those which makes up an individual pool description. For instruction, we'll be using CSV files to source our data, but your typical implementation is you would pull data from a database source. Over the next 3 days, we will develop a functional data store using the integrator tool, and then we'll consume that data store as a data source in the Studio portion of Oracle's Endeca Information Discovery product. We will create our data store via the creation of 7 Clover ETL graphs. The first graph that we'll create is one that we'll name Create Data Store, and it'll be a reusable graph to allow the Endeca server to decide if it needs to start a stop data store, attach an offline data store, or create a new data store. And we'll get into what all that means shortly. Then we'll create a graph that will purge a data store, and this again is another reusable graph, and what it will do is it will empty out all of the loaded data and configuration in a named data store. Then we will load into our data store search configuration, and so we will use those known features of the Endeca server within Studio, and we'll need to load some search configuration before we lay down our data in our data store. Then we will load our data, and we'll load those previously described CSV files into our data store, and then we'll load other configurations within the data store. This would be for grouping, for setting of attributes, and other things that require the data to be loaded before they get loaded. Then we'll load some pre-defined views of the data. If you have a SQL background, the Oracle Endeca Information Discovery product uses its own proprietary language called EQL. Very similar to SQL, but not quite exact. But these views will allow certain visualization components within Studio to use preloaded SQL or preloaded equal views. And then on the last day of our training, we'll use Studio to create various pages, and we will use some components to add a visual aspect to our data and actually look at how someone would go about analyzing the data, doing the data discovery that this tool is aimed at. The Oracle Endeca server is the query engine behind the scenes that provides your foundation for all your Oracle Endeca information discovery solutions. And so it uses proprietary data structures and algorithms that allow you to provide real-time response to your client requests. The Oracle Endeca server itself stores data files that were created after your source data has been ingested or brought in. After these data files are stored, Oracle Endeca server receives client requests via your applications and queries those files and returns the results. A D graph, or those ETL graphs we spoke of earlier, is the name of the process for which the data store is created in the Oracle Endeca server. Because the dgraph is key to every implementation, its performance is critical. A typical implementation includes the Oracle Endeca server running one or more graphs. The Oracle Endeca server is also designed to be stateless. This design requires that a complete query be sent to it for each request. The stateless design facilitates the addition of Oracle Endeca servers for load balancing and redundancy. Any replica of an Oracle Endeca server can reply to queries independently of any other replication. Consequently, configuring additional dgraph processes as nodes in a cluster increases the availability of request processing. If a node in the cluster goes down, at least one of the dgraphs running in the cluster continues to reply to queries. In addition, the total response time is improved by using load balancers to distribute queries among the nodes in your cluster. Oracle Endeca server also has web services capability, fits into the service-oriented architecture model of Oracle, and so it comes pre-installed with a set of versioned web services for loading, configuring, and querying the data. These web services provide an interface to the Oracle Endeca server, and you will see that when we build the graphs that a lot of the components we add within a graph are of a web service type, where we specify the commands that we want to send in, where we want to look at the response coming out of the server, or we're setting the Oracle Endeca server to run a specific process. The Oracle Endeca server is the core search analytical database, and it organizes complex and varied data from disparate data systems into a faceted data model. This is extremely flexible and reduces the need for upfront modeling. And so in the image here you can see that Studio, which is the front end, and we'll get to that on day 3, communicates through the applications that you build within it to the Oracle Endeca server. That Oracle Endeca server has been controlled, pre-configured you might say, with a data store from within the integration suite, which we'll spend days 1 and 2 on. And at the bottom of the diagram, those are the ingested, we might say, data sources. And so where you might have a product like OBIEE, where you end up with a communication between the system and your source data, this instead runs a communication and ingests the data into the Oracle Endeca server, and from there your Studio and your applications within it communicate with the Oracle Endeca server. The integration suite is a component-based ETL, extract, transform, and load tool, and this tool is used to create very simple or very complex data transformations within graphs. We will spend the better portion of the 2 of the 3 days operating within this tool set. Through the use of the Studio tool, our data will be available for searching, doing data analysis, and data discovery with an easy-to-use interface. As you can see there in the screenshot, you can get stoplighting, charting. We can also, and we will, go through an exercise of doing spatial analysis, plotting our data on a map as well. So there are many components that can be used to achieve a rich visual interface for our users to do their data work. If any taking this course have not yet purchased or not yet have an install of the tool set, these are the Oracle's minimum and recommended hardware requirements in case you need that information to make a purchase.